Hello everyone, welcome back to my channel Code and Codes. Today we are going to start something extremely important. If you truly want to become a professional C# developer, or if you want to work on a real world project, or if you want to understand large enterprise application, you must first understand object-oriented programming. Don't just memorize it, understand it. Today I will explain it in very simple possible way. Before understanding object-oriented programming, let me ask you something. When we write a code, what are we actually doing? We tell the computer, store some data, perform some action, produce some output. That's it. In every programming style, we wrote variable, function, and data or separate logic. And everything are separated. They are not connected. And this style of programming, we call it procedural programming. But what is the problem with procedural programming? Imagine you are building a banking application. You write account balance variable, deposit function, withdraw function, customer name variable, transaction logic. Now imagine your application grows. Suddenly you have 100 variables, 50 function, everything connected to everything. And now you don't know which function is modifying which data. And this creates tight coupling, hard debugging, difficult maintenance, and code duplication. And in large enterprise application, this becomes a nightmare. So then what is the solution? The solution is object-oriented programming. Object-oriented programming says instead of keeping data and function separate, we group them together. We combine data and behavior into a single unit and we call it class. And when we create a real usable copy of that class, we call them object. Now let's think in a real world term. Look around you. You see mobile phone, laptop, car, fan, and everything is an object. Now take a car for example. A car has a color, brand, speed, and a car can start, stop, and accelerate. Did you notice something? Here, data and the behavior are bind together. And this is exactly what OOP does. Now I will show you how this looks in C#. And these are the property of the car. Now let's define the behavior of the car. And here we write car stop. And here we define the class of car. We call class as a blueprint because this is not a real car. Here we just define what car have and what car can do. Now the question is, what is class? A class is a blueprint A class is a template. A class is a design. It does not occupy memory immediately. It just defines what properties the object will have, what method the object will perform. Here, these are the property the object will have, and these are the method the object will perform. Also, what is an object? Now watch carefully. So here we define the class of the car, and let's see, when I write car, my car equal to new car, here what does this code does is that here we define the object of the car. So to define the object of the car, here we write first we write the name of the class, that is car, then the variable or the reference variable, then we write the variable or we call reference variable, and then we want to create the new object, so we write new, and then we have to write the constructor. If you don't know about the constructor, we will talk about the constructor in the upcoming video, so do not worry about the constructor, just understand the format. First we write the class name, then the variable, and new for creating a new object, and then the constructor. So after writing this code, now something real is created in the memory. That means now this object has its own color, has its own speed, and has its own brand. Now we can say my car dot color equal to red. To access the property or the method of the object, we use dot operator. So car is the property of this my car object, so we write my car dot color, and in that variable we assign the value red, and also write my car dot start, so that the car will start. Now we can say this is something real. We can see the car is started. Now I'm gonna put a debugging point here and see how the flow work, and start the debugging mode. So here we assign the color, then we call start method, and it jump to the start method, and then it print car is started, and the program end. Now when we see this diagram, here we define the blueprint, and from the car blueprint, here we make the red Toyota car, and here we make the blue Honda, and this red Toyota is the object of this car class, and this blue Honda is the object of this car class. So object-oriented programming is a programming paradigm that organizes software design around the object rather than function and logic. An object contains the data and the behavior. We also call it method. Why OOP is powerful? Because it has code reusability, it is easy to maintenance, it has better structure, it can model real-world object, it has a scalable architecture. In enterprise level C# project, everything is object oriented. ASP.NET Core, OOP. Entity framework, OOP. Dependency injection, OOP. Without OOP, you cannot survive in large project. Now that you understand what class and object are, let's go deeper, because object-oriented programming stand on 4 powerful concepts. They are called 4 pillars of OOP. They are encapsulation, abstraction, inheritance, and polymorphism. If you understand this clearly, you will think like a software engineer. First, start with encapsulation. Encapsulation means wrapping data and method together and restricting direct access to the data. Let's understand this with a real example. Suppose we are building a bank account class and we don't want anyone to directly modify the balance, so we keep the balance private. Now I'm gonna go to the code and show how it is written. First I'm gonna comment this class because we do not need this. Then we create a deposit method. And inside here write if amount is greater than 0, then only we update the balance. I mean, we deposit to the balance. Also write the withdraw method. Here also we write withdraw double amount, and for withdraw we write the amount should be greater than 0. That means there should be some balance that we can withdraw. And also the amount must be less than or equal to balance, because we cannot withdraw 1000 if we only have the 100 in our balance. So if the condition is true, we deduct the amount from the balance. Now what happened? The user cannot touch the balance because it is private. So to update the balance, they must have to use this deposit or the withdraw method. And this ensure data protection, validation, control access, and this is called the encapsulation. Now let's call this from the main method. So first we have to write bank account my ACCOU and account equal to new bank account. Here we create the object. Now we can access the property and the method. So when I try to access the balance, I cannot access because the balance is private. That's why we cannot access the balance. But since the deposit and the withdraw are public, we can access them. So first we deposit. Let's deposit 1000. Let's also make the balance check method. So public void balance console dot write line balance, and you write balance. Now after deposit, call the balance check method to see how much is deposited. And withdraw some cash. Let's withdraw 100 and again check the balance. So now if I run this, what will happen is that here you can see first we deposit 1000 and after that we check the balance and it gives us the balance is the 1000, and then we withdraw 100, then we check the balance and the balance is 900. Now we come to the point abstraction. Abstraction means hiding complex implementation and showing only the necessary features. When we press the power button on the remote, do you know what happened internally? No, you just use it. Same thing happened in programming. Let's see a C# example. First I'm gonna comment this and also this, and then I'm gonna create a abstract class. Here I've created the abstract class of the vehicle, and we cannot use this abstract class directly, but we can create a child class from this vehicle, and the child class must implement this start, and user can call vehicle.start to start the engine, but they don't care how engine start. That complexity is hidden, and this is called the abstraction. We will learn more about the abstraction in the upcoming video, so if you confuse here, don't worry, that's normal. We'll deep dive into the abstraction in the upcoming video. What is the difference between encapsulation and abstraction? Encapsulation means hiding the data. Here we hide the data using the private access specifier, and abstraction means hiding the implementation. Those are a small thing but a powerful difference. Now let's jump into the inheritance. Inheritance means creating a new class from the existing class. That means reusing the existing code. Here in this diagram, we create a new car class and the bike class from the existing vehicle class. Now let's see how it is look in the code. Here I've created the vehicle class. It has a property speed and it has a method start. Now let's another class which is the child class of the vehicle. That is, we are creating here the car class and we are inheriting it from the vehicle. We are trying to inherit it from the vehicle class. So after colon we write vehicle, and after that we write public string brand. Here you can see the car has a property brand, but it is inheriting from the vehicle, so it also has the speed and the start, and this is without rewriting this method and property of the vehicle class. And this gives us code reuse, reduced duplication and logical hierarchy. So we can say a car is a vehicle and a bike is a vehicle, and this is a relationship defines a inheritance. Now we come to the fourth pillar of the OOP, that is polymorphism, and this is where things become powerful. Polymorphism means one name many form. Polymorphism allow method overwriting. Here in the vehicle class, the start method may have some their implementation, but when we inherit the vehicle into the bike, we are overwriting the start method with bike engine start, and we do same for the car. We are overwriting the start method with car engine start. Let's say in code level, here I am using the virtual keyword so that later on when I inherit this vehicle class and want to override the start, I can override. Without virtual we cannot override the start. Now let's create another class. And here I'm overwriting the start method with car started message. Now let's create the object of vehicle. V and new car. After that, when I write v dot start, we must see car started because here I'm using the car constructor. Here you can see we see car starting. Why? Because runtime decide which method to execute. and this is the runtime polymorphism. There are two types of polymorphism in C#. The compile time polymorphism, which is method overloading, and runtime polymorphism, that is method overriding. The example of method overloading look like this. Here in this overloading, both the method has the same name, add, but they have different parameter. Here it has int parameter, here it has double parameter. Also, it is different by the what it return. So depending upon what we pass in the parameter, it called the specific method. Now let's connect what we have learned everything till now. Object-oriented programming gives us encapsulation to protect the data, gives us abstraction to handle the complexity, gives us inheritance to reuse the code, and gives us polymorphism for the flexible behavior. When we combine them, they create a scalable, maintainable enterprise system. And this is why ASP.NET Core uses inheritance. Entity Framework uses abstraction. Dependency Injection uses polymorphism. And every domain model uses encapsulation. So OOP is not just a theory. It is everywhere in the real project. So today we have learned what is OOP, what is class, what is object, the four pillars of the OOP, how C# implement them. If you understand this clearly, you have no longer writing beginner level code. You are thinking in an object, and that changes everything. In the next video, we'll take each pillar and implement real world example step by step with debugging and memory visualization. Because knowing theory is good, but mastering implementation, this is what makes you a real developer. I will see you in the next one. Keep coding. Bye bye.